Okay, equations of circles. The equation of a circle is based on the Pythagorean formula. If I was to draw a circle centered at point A that goes through D, and I was needing to figure out the length of the radius, I could use the Pythagorean theorem or the distance formula. Because I can make, I don't know why it's not, I can make any right triangle on the coordinate plane by drawing a vertical line and a horizontal line and plotting this new point. Let's call this E. The coordinates of this point are 5, 2. So in order to use the Pythagorean theorem, I have to know the length of both of these legs here, because AD represents the hypotenuse because it's across from the right angle. This leg is 4 units long because it goes from 1 to 5. This leg is 4 units long because it goes from 2 to 6. So using the Pythagorean theorem, c squared equals a squared plus b squared. Four squared 16. So c squared is 32. Square root it to get exactly what c is. It's 4 square root of 2. To get about what c is, it's about 5.7. The distance formula is based on the Pythagorean theorem, because if I did c squared equals a squared plus b squared, and I wanted to get the c by itself, I'd square root both sides. You can see down here, A, the length of that leg was 1 to 5. The length of that leg was 2 to 6. So the distance formula is the Pythagorean formula without having to have it drawn. And I'll show you how that works. So D equals, now we're not talking about using this point anymore, point E. We're talking about the distance between A and D. So square root. So I subtract the x's, 5 minus 1, and I subtract the y's, 6 minus 2. 5 minus 1 is 4. 6 minus 2 is 4. And you'll see we're getting the exact same thing. So the distance between A and D, 4 square root of 2, or about 5.7. The equation of a circle is also based on the Pythagorean formula because all of the radii in this circle could be the hypotenuse of a right triangle on the coordinate plane. It's also related to the distance formula here, x minus x, y minus y. In order to write the equation of a circle, you need the center, and we'll call those two coordinates h and k, and you need the radius. Password is Noah. So the formula is 8x minus h squared, y minus k squared equals r squared. Okay, so let's look at this example here. Write the equation of each circle. So our center, I'm going to rewrite it neater. Our center is 2, 3. So when we write the equation, we know it's x minus something squared plus y minus something squared equals the radius squared. Now I wanted to write it like this because I want you to note that this x minus and this y minus are going to be part of the problem no matter what the center of the circle is. So when we write this, the x of the center is 2, the y of the center is 3, and our radius is the square root of 15. If there's any simplifying necessary, then go ahead and do that. So we have x minus 2 squared plus y minus 3 squared. And anytime you square a square root, they cancel. So when I square the square root of 15, the answer is just 15. And that's the equation of the circle. For B, we need the center and we need the radius. Okay, the center is going to be halfway between these 2 points. It looks like it's 0, 0, and halfway between -4 and 4 is 0, 0. And the radius is 4. So our equation, x minus something squared plus y minus something squared equals the radius squared. So x minus 0 and y minus 0 equals 4 squared. I'm going to simplify. X minus 0 is just x, so x squared. And then y minus 0 is just y, plus y squared equals 4 squared, which is 16. And that is your equation. Now I want to add 2 more examples. I want to write the equation of the circle that has a center of -3, -2, and a radius of 5. Okay, so we know our equation. It starts off x minus something squared plus y minus something squared equals the radius squared. Remember I said that this x minus and this y minus are going to be part of the equation no matter what the center is. So the x of our center is -3, and the y of our center is -2, and our radius is 5. So when I clean this up a bit, remember those become positive and those become positive. So our equation is x plus 3 squared plus y plus 2 squared equals 25. Then I want us to sketch this equation. X squared plus y minus 1 squared equals 9. Okay, so our center, since there's nothing being added or subtracted to the x part of our center is 0, and our y is 1. And remember, our radius is not 9 because when we write the equation, we square the radius. So to go back to the radius, we square root 9, so our radius is 3. So we're going to sketch this circle. And it's going to be a rough sketch because unless you have a compass, it's not going to be precise. So our center is at 0, 1, and our radius is 3. So I'm going to count out 3 to the right, 3 above, 3 to the left, and 3 below. And then I'm just going to sketch roughly, try to get it circular between all 4 of those points. Okay, something else it might ask you is if a point is on the circle, in the circle, or outside the circle. You can, if you have it drawn, you can just plot the point and determine. However, if you're just given the equation and you don't want to sketch it or you can't sketch it, then you can use the equation. So if I want to check that 3, 4, if it's on, inside, or outside the circle, I'm going to take this equation and I'm going to change the x to 3 and the y to 4. So I'm going to use this equation down here. So 3 squared plus 4 minus 1 squared, and I'm going to compare that to 9. 3 squared is 9. 4 minus 1 is 3. So I have 9 plus 9. That's greater than 9. So that means that point is outside the circle. So greater than is outside. less than is inside, equal to is on the circle.